Welcome to the first of two videos looking at how to conduct a MANOVA analysis using SPSS for PSY 4401. The data set that we are using for this task is the OCD dataset that you can find in the Before You Begin section of the 4401 Moodle site. Essentially, the scenario is that we are looking at the effects of treatment, being either cognitive behavioural therapy or behavioural therapy, on OCD. But in particular, we're looking at obsession-related thoughts and obsession-related actions. So we have a grouping variable with 3 levels: CBT, behaviour therapy, or no treatment at all. And then we've got 2 dependent variables, being the obsession-related thoughts and obsession-related actions. When you open your data file, you might notice that yours is slightly different to mine, and that's because I have added in an ID variable. It is a personal preference of mine that the ID variable always be the first variable in a data set, so that's why I have created it as the first variable, but it's perfectly fine for you to add it in as a later variable in your data set. You will do that in your variable view. You first of all, of course, need to name it, provide it with a label, and set it up as you would any of your other variables. The reason why I have added an ID variable is that we are going to need data that is a unique identifier for the assumption testing that we will undertake. So that is why we have done that. So as I said in the video for MANOVA, I'm just going to get rid of that. As I said in our video for MANOVA, best of all is, first step is to familiarise yourself with your data. So you can see here we've got 4 variables. Group is obviously our grouping variable. Actions deals with our obsession-related actions, and thoughts, obsession-related thoughts. If we look at our variable view, again we see that our grouping variable is nominal, and it's a good idea just to see how things have been coded. So here number 1 equals CBT, number 2 equals behaviour therapy, and number 3 is a no treatment control. So that's different from our ANCOVA variable, where our placebo or no treatment was coded first. So that's just a point of difference that I am pointing out. Now, the details of this example, if you wanted to read and get a little bit of background, you can find those on page 626 of your field text. Now, before we start our assumption testing, you'll also notice in terms of size, what's our sample size again? We've got a relatively small sample size of 30. Now, this is not going to be a problem necessarily for MANOVA. The rule of thumb for MANOVA and sample size is that your sample size must be greater than the number of dependent variables that you intend to test, and here we've got 2. So our sample size needs to be greater than 2, which it certainly is. However, 30 is certainly not considered large by any means, and indeed Hills suggests that you ideally would have 30 participants per cell in your analysis. So it's certainly could be considered a small sample size, which is going to potentially create problems for us in terms of normality and in terms of statistical power. But let's start looking at our data screening, cleaning, and assumption testing. So the first thing we're going to do is, just like last week in ANCOVA, we're going to look at the accuracy of the data entry. So we'll start with descriptive statistics and frequencies, moving over group, thoughts and actions, going into statistics. I always like to get the mean, but as I said last time, realistically it's the minimum and the maximum that I'm most interested in. You can always request skewness and kurtosis. I did not do that last week, but I will this week. And now let's see what happens with our outputs. So again, you can see that we've got 30 valid cases and no missing data in this data set, so that's a good thing. The mean for group, of course, is going to be completely nonsensical, and we're not going to try to interpret that in any way. And we can see that the mean for obsession-related thoughts is 4.5, And for, oh, sorry, that's behaviours, and obsession-related thoughts is 14.5. Now, in terms of skewness and ketosis, you can see here that we've got a negative skew for obsession-related behaviours and a positive skew for obsession-related thoughts. And all that's telling us is that our samples are they're different from normal. If they were completely normally distributed, those values would be 0. So the positive skew indicates that there are a larger number of low entries for obsession-related thoughts, and for the negative skew suggests that there is a higher number of high values for the obsession-related behaviours. And likewise with ketosis, we can see there we've got a value, our values are there. Basically what that is looking at is the peakedness, so essentially the height of the sample. If ketosis is below 0, we've got a rather flat distribution, and that's probably because we've got too many extreme scores. But here neither of them are under 0, so that's going to be okay. Looking at our range, we've got 1 to 3 for our group, so that makes sense, that's what we know it is. Obsession-related behaviours, we've got 1 to 7, which makes, that seems like a reasonable range. And obsession-related thoughts, 11 to 20, again, that seems like a reasonable range for the data that we're interested in. I would be concerned, of course, if this was something like 11 to 200, that would suggest a typing error that has occurred through data entry. Okay, so the next assumptions that we need to think about is whether our data is interval or ratio data. And so if we go back to our data file and have a look at the variable view, we can see that our dependent variables have been set up using a scale type of measure, so they will tick that box for that assumption. We need to consider whether our sample has been randomly sampled and whether there is independence of participants. So basically, can they do the participants only contribute data to one group? Now these are design issues, and we can assume that they have been met in this particular example. Next, we're going to look at normality and outliers. So first of all, because we're doing a multivariate analysis of variance here, what we need to do is we need to look at both univariate and multivariate outliers. So to start with univariate outliers, we're just going to go to descriptors again and do explore. We're going to move our dependent variables over. The statistics we're going to be looking for is we'll look for outliers. That will just provide that box where it will look at extreme scores. It's going to do plots. I like the histogram. And normality plots with tests is what we're after. So clicking continue and OK again. And as we scroll down, we will see, so there are our potential extreme values. Our tests of normality, now remember we want our KS and Shapiro-Wilks tests to be non-significant. But as you can see there, we've got significant values for all of our variables. So that means that normality may potentially be a problem in our distributions. And we can see that overall, in terms of obsession-related behaviours, we've got one side of our distribution that looks lovely, like it would on the bell curve. But this side, because we've got very low numbers here for 2 and 3, we haven't fulfilled that lovely bell curve shape. So there's potentially a problem with normality there. And again, if we look at our box plot overall, we can see that these figures that have been identified, these numbers are potential outliers. Now I'll call them potential at the moment because soon we will split our file and look at for outliers within each group, and that will confirm or refute whether they are outliers or not. And again, here we are looking at our histogram for obsession-related thoughts. Again, we've got this kind of building up nicely to a normal curve, but then it drops away very, very sharply on this side. So again, potential problems of normality, But realistically speaking, I'm not that concerned about that particular variable. The shape is not too bad. And when we look at our box plot to see if there's any outliers, there are no outliers identified there. So what I'm going to do now is I'm going to continue to look at for outliers, but to do that I'm going to first of all split our file, creating output, organising outputs by group, so that we can test for outliers based on our DVs. So once again, there are different ways of doing this. I know some people would now just use the chart builder to generate a box plot, but I'm going to go through the same procedure that we just basically did using Explore. So we don't need to, once you've moved everything along and ticked your boxes, it stays that way until you come back to change it. So realistically, I could have just opened this box and pressed OK, but I just wanted to demonstrate to you that they have remained unchanged. So a whole lot of output where really the ones I'm looking for are our tests of normality. Here you can see that we've got tests, we're in the CBT group, and here normality is not a problem for either of our variables, and you can see that's looking not too bad, not too far from normal, and again our box plot is looking lovely balanced. Two tails, both an upper tail and a lower tail, and that mean about in the middle, so that's not looking too bad at all for us here. Obsession related thoughts, that's certainly not normal because we've got several high peaks, but again our tests of normality have come back okay, and our box plot looks all right as well. Looking for our behaviour therapy group now, if I look down at our tests of normality, we do have a potential violation here in our obsession related behaviours because we've got a non-significant result there. And again, looking at, you can see our histogram is actually looking like two separate distributions realistically speaking. And down we go to our box plot. Again, you can see that mean is pushing up, but what you should be noting is that there are no outliers that are being identified within these groups. And if that pattern continues, then we will be able to conclude that there are no outliers and we do not have to do anything to our outliers or transform our data in any way. Again, that is not perfect, but it's still acceptable. And then finally we're at our no treatment group, so just scrolling down to our tests of normality. Again, most of them are actually not most of them, two of them are non-significant, but the obsession related thoughts is significant on both of the tests, so we've violated normality there. But the problem is, do we have outliers? No, we don't. We just have atypical shapes for that. So an alarm bell should be ringing. We have got violations of normality, but because this is a learning experience, let's keep pushing on. I will come back to this idea of multivariate normality in just a minute, but to do that I need to pull the file together. But there's one step later on that I'm going to need to do with a split file. So while I've got the file split, I'm going to do the next assumption, which is checking for linearity. Now we'll do that through looking at scatter plots. So we'll go to graphs and chart builder. If that one comes up, it's just a message, but you can just click on it to ignore. You want to click on scatter or dot, and we just want a simple scatter. Now, using your mouse, drag your DVs into the X and Y axes to generate your scatter plots. Okay, and then click OK. And you will see in your output that you have got the three graphs, one for CBT, one for behaviour therapy, and one for the control condition. Now, what is missing from those graphs that you need is a line that will, the regression line. So what we're going to do is I've just double clicked on the graph, and I'm going to go to elements, and I'm going to go to fit line at total. And that is adding that line for me. And essentially we want that to be a straight line. Now you can see it's got a label there. I don't mind whether you leave that there, but if that label's going to annoy you, you can just tick that little box over there and apply, and it will get rid of the label off the line. So again, that's a preference thing, but some people I know have issues with the label being on the line. So I've done that for our CBT group. Doing it again now for our behaviour therapy group. Elements, fit at line, and again I'll take off the label. So perhaps when I say I know people have issues, maybe I mean I have issues. And closing that. And then again for our no treatment control. So what we can see is that we are getting straight lines. They might be horizontal, they might be diagonal, but what we are doing is we are getting the straight lines as expected. So our linearity assumption is fine. Okay, so now going back to assess my multivariate normality and outliers, I'm going to go analyze cases, all cases, so don't create groups, and we can see in our syntax that split file is off. And so to generate, to assess multivariate normality, what I need to do is I need to find Mahalanobis's distances, and so I will do that by doing a regression analysis. So I go analyze, regression and linear. This is where we need our participant ID. So our participant ID, which is unique data for every case, is going to go into the dependent, and then our two dependent variables, so I'm just holding down the shift key to highlight both, are going to go into the independence box. What I'm going to do is I need to click on save to make sure I choose Mahalanobis's distance, and then I'm going to go to continue. If I was doing this regression for any other reason, I might choose other options and plots and all of those things, but literally this is just for assumption testing, so that's all I'm going to do, and then I'm going to click OK. I'm going to ignore most of the regression output, and indeed the only thing I'm going to look at is this residual statistics box, and you'll see the line there for mile distances, and in particular all I'm looking for is the minimum and maximum value. Now, Tabachnak and Fidel outline a chi-square critical value table. Some of your SPSS guides sometimes include the critical values. I'm just going to tell you that the critical value here for two dependent variables is 13.82, so we want our maximum value to be below 13.82, and it well and truly is. So we know that we don't have any problems about multivariate outliers and multivariate normality. I'm just going to bring you back to your data file for a second to show you that because we had clicked save for that assumption, we now have a new variable in there, MAH1, which is essentially Mahalanobis's distance values that you've saved from your analysis. Okay, now there's one other assumption that we need to assess, and that is multicollinearity and singularity. And to do that, we just need to generate some correlations. So we go analyze, correlate, bivariate. We're going to put just our dependent variables over. Now, ideally, we are looking for MANOVA works best when we've got moderate correlations between our dependent variables, and multicollinearity is going to be indicated. Generally speaking, my rule of thumb that I use is a correlation above 0.9, but I have seen in some sources that a correlation above 0.8 is considered problematic. So I've got my DVs over in the variable box, and I'm just going to click OK. And that generates my correlation table, and I can see that the correlation between obsessive related thoughts and actions is 0.059. So that's certainly not going to be a problem for multicollinearity. So that brings us to the end of our assumption testing for MANOVA. There are actually two other assumptions that may need to be considered if you are going to be performing a MANOVA. One is homogeneity of regression. However, you only need to perform that assumption test if you're going to be performing a step-down analysis for your analyses that you're going to do after your main analysis. Now, we are not teaching you that in 4401, so you don't need to do that assumption test, but I just want you to be aware of it because I know that your Hills SPSS book, that is the additional analyses that they perform, so there is content in there about that. And the other assumption that you need to perform, which is unique to MANOVA, is the homogeneity of variance and covariance matrices. But this is done as part of your main MANOVA analysis. So we will do that in the next video.